Hi folks, before we get started today, I just wanted to show you this sign that hangs at the back of my workbench. It's a constant reminder we're dealing with high voltage, even lethal voltages inside of tube electronics. I cannot be responsible for the actions you take by watching my videos, so hopefully you've had some basic electronics, understand the safety precautions and procedures in dealing with high voltages, and so we can have a lot of fun and be safe. So let's get going. First of hopefully many videos by Blueglow Electronics on the restoration, service, and building of hi-fi audio equipment, mostly focused on vintage equipment, but every once in a while we get some new stuff in the shop as well. This happens to be a Magnavox console amp from I believe 1959. It's an amp 8101000. It's actually a 3-channel amp with 3 sets of 6V6 GT tubes and in push-pull configuration, using some 12 AT7s and 12 AX7s for the drivers and some 5U4 tubes, 2 of those actually in parallel for the rectification. And this is pretty much the shape I got this amp in. It's a friend of mine. He actually brought it to me a month or 2 back, but I've had some surgery and couldn't really work on it. So he wanted it done by Christmas, so here we are in the witching hour trying to get this thing done. Basically what he wanted done to it was he wanted it modernized so that it could be used, given to a friend of his for a Christmas present. And he wanted, basically upgraded, everything checked out, wanted it to be able to be used as just a simple 2-channel stereo amplifier. So we started on this thing early this morning, and I thought I'd walk you through what we've done thus far to the amp. You can kind of see here on the top a couple of places that are missing. Those actually, there were 2 connectors there. One that connected to all the speakers inside the console amp, and then the other that fed to the tuner section and the power switch and things of that nature. So those were disabled from underneath, and I can show you a little bit more of that in just a second. On top here is this little box that I removed. Underneath it were some inductors that were used as part of the bass and treble circuit. And I want to take this thing back as simple as possible, pretty much a straight through configuration out of the inputs, straight into the 2 12 AT7 drivers, into a pair of the push-pull 6V6s, and out the back. And I'll show you a little more as we go along. We flipped the amp upside down now. You can kind of see at the front here there was a connector that went to a secondary set of connections inside the amp and inside the console, and we disconnected those. We basically went through all the coupling capacitors here in between the preamps tubes and the output tubes, replaced those. The cathode bypass capacitors we've replaced. Pretty much everywhere there was a capacitor of any type inside this amp, we've replaced it. There were a few older mica type caps that we left in place, but I tested those out. There was an electric lytic here in the bias circuit, 25 microfarad, 25 volts, that we replaced as well. For the most part, that was it. Not quite done with the amp. I've got a few more things left to do to it. I've actually got to wire up the power cord. I've got to wire up the power switch and an XY safety capacitor, and probably a CL80 thermistor, and I'll show you that here in a minute. You can see here on the back of the amp, we basically just mounted some simple little RCA connectors. Drew a horizontal line on the back of the amp, used a drill press, drilled out I think 8 holes total, moved the power cord to the back, put a fuse holder in place, 2 banana plug jacks, and 2 RCA jacks on the back here for the input. And I've not, as you can see on the other side here, I have not yet wired those up, so you'll get to see some of that in action, hopefully. These can be amazing sounding little amps. I've probably done 30 or 40 Magnavox console amp restoration services in my day, and many other types as well, RCAs, Toshibas, Voice of Music, Packard Bell, many different ones. But this nice little amp here, we'll keep going and show you more as we go along. Show you all the old capacitors that I removed. You know, it's one of those things, you can pull these out and test them, and sometimes they're good. Matter of fact, a lot of times they are, but you know, it doesn't take but one to be leaky and you know, let some DC into the wrong part of the circuit or whatnot, and you end up with glowing red tubes in the output. And so it's really just better to replace all these. And as you can see in the amp, I used a combination of good old orange drops, Sprague orange drops, and then I used just a couple polyester capacitors. You also see here the old, what they call death capacitor or whatnot, that goes across the power input leads that I always replace with a nice new XY safety cap. I'll show you that here in a second. Cap on the right, same thing, 0.01. Usually these are rated about 600 volts or so. The XY safety cap, and that'll go across the two input leads. To the left here, you'll take one leg of the input circuit and you'll basically run it across this, you'll run it through this CL80 thermistor. And these things really serve two purposes these days, and I'll always put one in these old amps or anything I'm working on, whether it's a Fisher stereo, Fisher 500 or something like that, or whatnot. But first purpose is it helps drop the voltage a little bit. These things take a couple volts off the input, and most of these older amps were built when line voltages were a little lower than they are today, so that helps out. But more so than that, these things power up slowly, so they help bring a little bit of slowness to the inrush current that if you just flip the power on without one of these, hits the tubes pretty hard with an inrush current. So this helps slow that down a little bit, and just kind of a general hygiene thing for the amp, in my opinion. So we do that. And we're going to wire up the fuse holder. I just got done soldering one lead of that. Got done soldering the other lead of the power line to the terminal strip up here. And we'll finish this up and show you the results here in just a second. You can see that I wired the XY across the two power leads coming in from the mains power source. And then I took one leg of that and went through the CL80 and then into the primary of the transformer here. And kind of tucked the wires away neatly here. I will tell you, I had to remove quite a bit of excess stuff inside this amp as I was working on it. It just had various connections that were no longer needed. The center channel I completely removed, basically all the circuitry inputs and outputs to that. Just try to clean the thing up and tidy it up a little bit. These things never were the neatest looking amps underneath. They kind of came like this from the factory, but I can tell you now it looks better than it did a few hours ago, and we'll keep going at it here. One thing you can see up here on this end, you can see the power switch that I put in place that you'll actually access from the top, and I'll show you a little more of that here in just a moment. One thing I thought I'd show you, if you've never seen a set of these, they're little crimp tools specifically made for these little stress relief holders that go in and out of power cables. And I'll tell you, these they're not cheap, about 30-40 bucks for a nice set of them. Kind of act on a capillary action here where they squeeze together nicely. But man, are they worth having a set of in your shop. I'm a firm believer that you cannot have too many of the right tools. So I buy a lot of high quality tools, a lot of high quality test equipment. But I've been at this for at least 30 years now, and most of what I bought over the years has stuck with me, and I've used over and over and over the many years. So just some food to thought if you're just getting into the tube electronic stuff and wanting to get started in this stuff, and you think you're going to stick with it. spring for a little extra for the high quality stuff. It'll last you a long time. Back around to the top of the amp. You'll notice a couple things here I've done. One, this thing had two 5U4 G rectifier tubes in it. In parallel here, I've pulled one of those. This thing really doesn't need the current draw that both of those have, unless you got the center channel activated inside this thing. So just running it with one, you could put the second one in there if you wanted to, but in my opinion, you'd just basically be burning out a tube over a period of time. You'd be better off to put that second tube in a drawer. And then when this first one goes away over time, you would have a nice fresh one in the drawer to pull out and put on. I also removed the 12AX7 that was the input for the center channel here. It's no longer needed, and these two 6v6s here were in a push-pull configuration for the center channel. So we've removed all those at this point. So basically we're coming in the original inputs here, which I'm about to disable because we're going to go to the ones on the back. But you're feeding into the two 12AT7s and coming out of the two 12AT7s into these push-pull pairs. I use my lovely TUV7DU tube tester, which is by far my favorite tube tester. I've also got an ICO 667 that I use for compactrons. And I've got a Amplitrax AT1000 that I use when I'm selling tubes and want to match them and print off receipts or whatever, to spec sheets to kind of go along with them. But it doesn't get as much use. The TUV7 gets by far the most amount of use around here. But I went in and matched two pairs, kind of the A pair and the B pair, and made sure that the tubes from a transconductor standpoint were fairly well matched. I'll do a little more testing on that once I get the amp all fired up, and I'll actually do current balancing versus just mutual conductance, the transconductance there. You can see here the power switch that I mounted on the top. These are really easy to do. You grab a drill bit and you drill a little pilot hole. I use a sorry, my son came in and interrupted me, but you drill a pilot hole, maybe a 1/4 inch bit or so, and then I use a Greenlee punch, like a chassis punch, to drill out the remainder of it. It's a 3/4 inch hole. When you get done, you have to use a little Dremel to notch one side over here, so that because this power switch, when you slide it down in there, has a little plastic ridge on one edge to keep it from turning left and right. But makes a really nice power switch right here on the top, and I do this on just about every console amp that I restore. This thing's got a bias, a channel balance between left channel and right channel there, still active. This treble and bass things here I disable just to get them out of the circuit per se. I'm a big fan of just straight through audio, no equalization and that type thing. And I did want to tell you here, use this little handy Peak Atlas ESR tester. It's equivalent series resistance. Basically sends a high frequency voltage signal through a capacitor and is able to not only measure the capacitance of it, but also measure the equivalent series resistance. In other words, is the capacitor starting to break down or not? And believe it or not, this capacitor, even though from 1959, is still standing tall and proud and not very leaky, less than an ohm or so of resistance in each of the legs. And most of the values were pretty much spot on. I'm a fan of not replacing something unless it needs it. Every once in a while I get a customer that says just do it all, and I will, but it just racks up a lot of dollars. This thing might last another 10 years the way it is. It may go another 20, and it may die in a year, but you just never know. But then again, a lot of the newer capacitors you buy these days, they may die in a year or 10 years. So it's hard to get good quality stuff these days, and a lot of fake stuff out there. So it's hard to tell when you're getting good quality stuff or not anyway. But anyway, just want to let you know that's an amazing little tool. I've got a bunch of these little Peak Atlas meters. I got a LCR, this one, and a semiconductor tester, but they're about $100 a piece, maybe $89 if you catch them on sale, but definitely worth their money if you're getting into this line of work. And we're going to do a little more soldering underneath, get these get the inputs soldered to the where they need to be, and the outputs soldered, and then we'll be back around. You'll see here I'm a big fan of is cloth covered wire. You can see I got spools and spools and spools of it. Solid core. It's great stuff for doing all sorts of wiring within amps. Really easy to work with, really good insulated, and it just gives it that old vintage feel to it. So thought I'd show you that for a real quick second while I jump into this thing and strip some cloth. And one other thing I want to show you real quickly while I was about to do some soldering. Unfortunately, I'm using some 6040, just standard Radio Shack, fairly thick solder here on the left for most of my lead connections. And I'm using that because today I ran out of my Alpha Metals solder. This stuff is 6337, so tin 63%, lead 37%. Whereas this is 6040. I'm a big fan of the 6337. I've got lots and lots of this stuff and the really fine stuff, but I was needing the little bit heavier gauge stuff today, and I'll be ordering some more of that, but I thought I'd show you what I did most of my soldering with. And back here while I'm at it, I'll show you my favorite soldering iron of all time. I've had dozens of soldering irons, Wellers, you name the brand, I've just about had them, and this Heiko, fairly new model, it's a FX888D soldering iron. They're about 90 some bucks on eBay, and just an amazing soldering iron. Heats up very quickly, does a great job of heating whatever you need to heat up, short of anything directly hooked to the chassis. And been using this thing, I'm on my second Heiko actually. Used the first one for a couple years, and I'm about a year into this one, and really nice little units for the money. Get the nice little stand here with the Brillo pad type brush there, and then the nice sponge on the bottom. I usually walk around the house and my teenage kids leave half-drank bottles of Aquafina water. I'll snatch them up and sit them in the back here, and then I use them to keep my sponge wet as needed there. Always want to observe the high voltage sign here. As we work on any of this electronic stuff, you always have to assume this stuff is live. You know, it's pretty risky stuff what you're dealing with, and there's lots of rules. You know, only one hand inside the chassis at one time, keep your other hand away, never use both hands at one time, things of that nature. I'll show you a little something down here underneath the thing. I use a little, just a variac down here that it's pretty neat. You can actually see my foot here, but I flip the thing on and off with my toe. Works out really well, but I have it wired up here to a kilowatt little voltage meter, and this thing tells me exactly as I dial the variac exactly how much voltage is going in here. I can tell how much current this thing's drawing, total power output going into the thing. So I know anything that I plug into that outlet right there is going to be controlled by the variac down here, and I can flip it on and off with my foot, which is very, very handy, believe it or not. And we'll talk a lot more about the rest of my shop here as the days go on and we get into doing more of these videos. I have been a little bit about myself. I've been restoring, working on, and servicing vintage electronic stuff for, like I say, about 30 years. Got an electrical engineering degree back in the late 80s, early 90s, but never really used it in my career. I got into computer systems, then got into computer networking, and I don't know, for the last 10 years I've been working for very large corporations as basically an IT architect for large systems. And so the days can be full of politics and stress and corporate America and whatnot. So this is what I come home in the evenings and do, and probably do some tours of the bench. I keep most of my storage in another room, and you'll get to see lots of that over time. The bench here I have is fairly simple. I'm a real big fan of simplicity, but yet having the right tools, so you'll see a lot more of that as time goes on. At any rate, I got to quit getting distracted and get back to this thing. So Give me a few and I'll be back here in just a minute. I'm going to show you something here. I'm soldering the ground wires of these input. It's on the RCA jacks, and the way this amp works, pretty much the chassis is ground. So I'm going to go as close as I can to these things straight up here to a terminal lug that actually goes right down to the chassis there, you can see. So it's pretty straight run. Another option I could have would be bend these tabs over and kind of scuff up the surface here and solder them straight down here. It's just a whole lot harder, and no further than that is to the closest ground. I went ahead and went this path, but just thought I'd show you that. One other thing I'm a firm believer in is always to use your wire in a physical way to connect to things and not let the solder hold the wire to something. So you can see up here at the top, I ran the wires through, and then I physically bent them around in a U shape to hold them to the terminal strip. Similarly down here, when I soldered both of these things, ran the wire through, made a teeny little U-hook, hooked them through there, and used the pliers to bend them and hold them tight. That way you're not using the solder to physically hold the wires in place. The wires would stay on their own without the solder. It's one of the things I see the most when I get into a restoration project. I work on a lot of Fisher gear, Macintosh gear, Scott, whatnot. People bring me the equipment, and basically I get it on the bench, and somebody over time has done some work in it, you know, inevitably, because most of this gear is getting on up there 40, 50 years old. And yeah, I won't say a lot, but, you know, 1 out of every 10 times or so, I'll get in there poking around. And by the way, the best poker in the world, I keep it right here in my handy dandy little roundabout, as you can see, is a bamboo Chinese chopstick. But I get in there poking around with the thing on, and all of a sudden I find sure enough, I'll find a cold solder joint or a solder joint that's broken loose over time, and you got this wire just barely making contact, so it's half working, half not working. And you start looking at it, and lo and behold, and exactly what I was talking about, somebody used the solder to make the physical connection, and just over time, the physical tension on the wire or whatnot has caused the solder to break loose and left you with this intermittent type scenario. So just some more of my tips here. You can take them for what they're worth. You can ignore them. Doesn't matter to me, but I thought I'd share a little of my wisdom. You know, one thing I've learned about electronics and servicing over the years like this is that everybody's an expert, right? But yet everybody points out what everybody else is doing wrong, this and that and the other. I'm just a firm believer that you follow the basics, and you kind of learn tricks and tips over time. Anytime I run into anybody, you know, I watch a lot of videos online. El Paso Tube Amps, a great set of videos to watch out there if you haven't. Uncle Doug's got a series of stuff. And, you know, most of the stuff I watch, it's kind of reminiscent or nostalgia for me as I'm watching it, because they're doing a lot of the same things I would do them. But every once in a while, I'll see them do something, and I'll say, wow, hadn't thought of that shortcut, or hadn't thought of that tip, or, hey, that's a neat way of doing that. So, you know, I'm a believer in, you know, smart people only get smarter by surrounding themselves with people that may even be smarter than they are, and continuing to learn. So I'll never claim to know it all, and I'm sure I'll get lots of replies as I do these things to my videos, telling me what I did wrong or could have done different. For example, I know I could have replaced this power cord with a 3-prong modern safety cord, but actually the owner, the guy, didn't want that done, so I just kind of wanted to keep it as much vintage as possible. But those are the types of tips and things that you know, I always learn and pick up new things. And real quick, while I got this thing here, you can see the original capacitor still in place there, and like I say, I tested that thing out really well. You can see the bottom side of the this one on the left here is actually the balance, and the ones on the right here, which are kind of out of the circuit now at this point, are kind of pegged all the way over. Those were the balance and the treble, and we're getting ready to take these 2 input leads right here, which are feeding down to the balance pot, which then feed over to the input circuits of the 212 AT7s. Going to do a little bit of playing with these resistor values. when I was playing with it a while ago, I thought this amp could have been a little bit louder than it was. I was just running banana jumper wires all over the place to get it running. Before I went drilling holes in the sockets and whatnot here, I wanted to take the thing the way it was original and make sure it worked. So I had it on the bench for a couple hours this morning testing everything out. We'll play a little bit around with these input resistors here a little bit. Might tweak a little bit more drive out of this thing. We'll see here. And then towards the end, we'll hook this thing up to a bunch of test equipment, which I'll get to show you, and we'll kind of go from there. I'll be back in a few. Going to do a little bit more soldering. One other thing real quick I was doing along the way, and hey, bear with me. This is my first video. I'll probably get better at storytelling and not jumping around so much. But these little EX Tech, this is an EX330 auto ranging multimeter. Great little units. I've got flute meters around here, lots of different kinds of good stuff. But for the money, this is like 58 bucks. Great little unit, by the way. I was just using it to do some continuity testing on something over here a minute ago. And I'll show you a couple things I'm doing right now. So I got the inputs all soldered up, and I'm running some jumpers from these input wires, kind of taking it back here and going to where the original inputs are. And that's why I say I want to just play around with some various resistor values here to see, maybe even take them completely out. We'll play around with that. Coming out the other side over here, this will be a little interesting for you. These are where the outputs are currently wired up to, and I have to stand these things up, make sure that they're not touching anything really well here in a second. And you can see the other side of this thing. Basically the green's hot and the blue is ground, but that's how I've got the outputs wired up. These wires kind of come around here on the bench, and then they go up, and you can see they go up into something. And what they actually go up into is a dummy load setup that I've got here. Two 500 watt resistors inside of this little chassis. This was an old HP BNC access switch that I gutted the chassis and basically put some 250 watt 8 ohm 1% resistors inside of. Wired them up. I got all the outputs tied then to these BNCs, which feed various pieces of test equipment you'll see a little later. One of them, which is my handy HP 8903 audio analyzer that I've had for a long time and truly adore. I've got switches here on both sides. So left input, I can either have it going to speakers, which if you look up here on top of my chassis, you can see I've just got some bookshelf speakers. I think there's JBL of some type. And then I can also switch to the dummy load either way. And similarly over here on the other side, I can do the exact same thing. We'll get into a whole lot more of my test equipment as we go on through this. But I'm gonna hook up some music to this thing, man. I've had this a while. It's a just a little old iPod Nano. You can pick these things up for like 40 bucks, and just use a little mini 1/4 inch or 2.5 millimeter, I think it is, RCA jack into the RCAs, and we're going to power this thing on here in a second and listen to it. You can see down here we'll use our trusty foot switch here. Use my toe to flip it on. I love that because I don't have to use a hand. I don't have to reach to turn it off. I can reach over with my foot just like that and turn this thing off. At any rate, it's on. I got a big red light down there telling me it's on. Over here, I've got the kilowatt. If you'll notice, this thing is sitting at 120.4 volts right now. And I got a big red light and green light right here telling me that this thing is on at this point in time. So it's really easy for me to know when this thing's on or off. Right now we are running on, and you know, I have not wired in the power switch yet. I have not wired in the fuse to this thing yet, but got to do that here in 1 second. I'm going to take a pause to the bin and got me a nice spool here of this red cloth covered wire. That's what I'm going to use to run here from the input over to the power switch and back over here to this CL80. But just thought I'd show you that. This stuff's not very expensive. If you buy it in bulk, you can get like 12 rolls, and it comes out about $6 or $7 a roll, but well worth having. Another tip while I'm at it. So if you notice, I'm running this red wire from over here, like on the output of the fuse holder. I ran it all the way around the right, all the way down around and hooked it up, and I'm just kind of measuring this off. Hey, I don't worry when I cut too much. I'd rather overcut the length and have to shorten it than worry about coming up too short. Besides, I keep this little bin here, and I've got hundreds of these bins around the house. Probably not hundreds, but probably 50 or more. And what these are, where I've overcut wires or cut wires out of chassis or whatnot, and I just throw little scrap wires in here. You can see here's a piece of the brown cloth wire from some other time, but this stuff gets used. Half the stuff I wired inside this amp today, this is where the wires came from. So always save your old wires, especially the cloth covered stuff. It's really good stuff, and use it again later. The other thing you'll notice, I'll end up tucking these wires along, but I'm basically going around the outer part of the chassis here for a reason. I'm going the furthest away from the audio signal. So you got the inputs back here feeding in. You've got the actual audio circuits themselves over here. I'm trying to stay far away from those. Okay, we're back. Finished wiring up this thing. Just used some yellow wire here. Could have used a lot of different colors, but it's pretty simple to follow and trace. And I had this blue yellow wire out, so I used that. Still got to tuck all the wires up, use some strip ties, get it nice and clean. But as you can see, we got input feeding in, got it all wired up, got it powered on at this point. And when I hit the play button on my little iPad here, we get nice music coming out of this thing. Probably run it through the 8903B and run some Pete Millett's frequency response and THD, total harmonic distortion measurements. But for right now, I just want to kind of play this thing for a couple hours. One thing I'm a big believer in is hours of burn in before you hand something back over to a customer, because often little things will creep up, noises, pops. If an electrolytic's acting up, that'll start happening, just various things. And I always like to burn in a good 4 or 6 hours on a unit. So I'm going to go ahead and start some of that by letting this thing play for a while, make sure everything's working good before I go and tidy it up. You spend a lot of time routing cables, getting them zip tied and whatnot, only to find out you got an issue and you got to undo all that. So, and on top of that, the frequency response and THD and all those measurements, they're great. They kind of give you the qualitative, I would say, measurement of an amplifier, but it's not till you actually hook an amp up and play it for a while that you really get to understand how it sounds, and the ear is the ultimate measurement device in my opinion. So keep playing with it, and I'll keep By the way, I figured out holding my iPhone is not the best way to do these things. So hopefully the future ones will be a little better. And this thing is sounding amazing, to be honest. Keep you posted. We'll keep the videos rolling. Please check out my website, www.blueglow.net. Lots and lots of pictures there of restoration jobs and service jobs I've done over the last couple of years. Since I started taking pictures. Before that, I just did the work. But real appreciate everybody, and we'll be back soon with more for you to see.